All right, let's see if we can look at other problems in different contexts, not necessarily just adding and subtracting numbers, but maybe we can think about this idea of parity in other different types of problems. So here's another problem. We have a 5 by 5 grid, and the question is, can we completely cover it with dominoes without any overlap? And the dominoes we know are of size 2 by 1. So each domino is going to look, so let me draw the grid here. I'm trying my best here to draw a 5 by 5 grid. And we know a domino is going to look like this. It's just a 2 by 1, so it'll be 2 squares, 2 by 1. So for example, we can put a domino like this, then we can put a domino like this, then like this, and so on, like this, and keep doing this. The question is, can we fully cover this grid without any overlap and without any dominoes being outside the grid? So that is, can we perfectly cover it with dominoes? All right, take a minute and think about this problem and see what you get. All right, so hopefully you probably tried the problem and realized that we cannot do this problem. It's not possible to cover it up. Again, though, some of you might have tried different possibilities. But notice there's many different ways to arrange the dominoes on your board. There's so many combinations that you can do. But what is true? In the end, no matter what you've tried, you'll find that you will be left with exactly one square, which of course cannot be perfectly covered with one domino. The domino will either overlap another domino inside the grid, or it will extend to the outside of the grid. So you would declare that it's impossible. But can we actually prove it for sure without trying a specific arrangement? Can we explain that it's impossible without even placing the dominoes? How would you do that? Take a minute and think about how would you explain this without showing any kind of arrangement here on the grid. Okay, so one explanation is the following. We have a 5 by 5 grid, so how many squares are there? 5 times 5 equals 25 total squares in the grid, and each domino is equal to, it's a 2 by 1, so it's equal to 2 squares per domino. So to find whether it's possible that a bunch of dominoes and each one is 2 squares, and if we multiply the number of dominoes times the number of squares in each domino, we need to get 25, right? Well, if we take 25 and divide by 2, if we just think of multiplication as just division, what do we get? We get 12 with a remainder of 1. Or alternatively, you can write 25 as 2 times 12 plus 1. This immediately shows us that we will have an extra square that will not fit with the other dominoes, and it will not be able to be perfectly covered with the domino, which is 2 squares. So this calculation shows us it's not possible. Or you can think to yourself, I have D dominoes, so I need to take my D dominoes and multiply them by 2 squares per domino. For example, if D is 10, 2 times 10 is 20 total squares. If I have 10 dominoes, they'll cover 20 squares. If I have 5 dominoes here, they'll cover 2 times 5 squares, because each domino is worth 2 squares. So is it possible for 2 times D to equal to 25? Well, this is an even number times either an even or an odd number. We don't know how many dominoes we'll need, but the point is it doesn't matter because we're multiplying it by an even number. So even times anything is equal to even. Even times odd is even, and even times even is even. So therefore, it's not possible for us to cover 25 squares, which is an odd number, with 2 times the number of dominoes. And we are done.